so this is our second lesson video for section 8.2, and so make sure you really understand the first lesson video before you try to tackle this one. Alright, so things that you'll want out during this video are a periodic table with the valence electrons labeled across the top, and you'll want to remember our list of steps to draw Lewis dot structure. So that's add our valence electrons, bond the atoms, make sure everybody has octet or hydrogen has a duet, and then check our total. We are going to add one step to this for our multiple bonds. Alright, so a double bond occurs when two atoms share two pairs of electrons, or 4 electrons. It's represented by 2 dashes, which equal 4 electrons. So in the first lesson video, we did single bonds. So that bond has 2 electrons. A double bond is just 2 dashes, so each dash has 2 electrons. That's 2 4 electrons. And then a triple bond occurs when 2 atoms share 3 pairs of electrons. It's represented by 3 dashes, and that equals 6 electrons. Now, in reality, can you go above a triple bond in upper level chemistry? Yes, you can. In this class, we will not. So if you're trying to do a quadruple or quintuple bond, just start over because something has gone terribly wrong. Alright, so when writing Lewis dot structures, follow the 4 steps that we already learned in the previous video. However, the thing is, when you add up the total number of electrons in your Lewis dot structure, sometimes it's not going to equal your total from step 1. So if you watched the previous lesson video, every time we got to step 4 and checked our total, it magically worked out that it equaled the total from step 1. Sometimes that doesn't happen. Now sometimes it's because you might have made a mistake. You might have actually tried to give hydrogen an octet instead of a duet or something like that. Maybe you added up your valence electrons wrong. But the majority of the time, if you follow step 1 through 4 correctly, when it doesn't work out, it means you need to go to step 5. That means you need a multiple bond. For every extra pair of electrons you have, you need to add one more bond to your structure. Okay, so let's say 2 extra electrons equals 1 extra bond. And then I'm just going to put under restabilize, because you have to then make sure everything still has an octet and a duet. For Lewis dot structures, multiple bonds seem to be the hardest for most people. So just focus a lot. I'm going to try to go extraordinarily slow on this. That's why it's going to be its own lesson video. Alright, so it says write the Lewis dot structure for the following. So we have O2. So first step is, of course, add our valence. So oxygen is in group 16, so it has 6 valence electrons. But because there's 2 of them, I'm going to do 6 times 2, which gives me 12 valence electrons. Alright, so step 2 is bond the atoms. So since there's just 2 oxygens, my only option is kind of like this. Step 3 is follow the octet and duet rule for hydrogen. Well, oxygen, of course, follows the octet rule, which means I need both of them to have 8. So right now they have 1 bond, which is 2 electrons. So how many more does it need to get 8? It needs 6 more. So I have 1, 2, 3, 4, 5, 6. So see, this one now has 2, 4, 6, 8. And then I do the same thing over here. So it has 2 right now, so it needs 6 more to get an octet. So I do 1, 2, 3, 4, 5, 6. And so now this one has 2, 4, 6, 8. Now this is where it's about to get tricky. Okay, so just hold on. The good thing is this is a lesson video, so you can rewind it and watch me do it over and over again. In class, I just have to keep showing them over and over again because they keep asking. Alright, so step 4 is check my total. Okay, I'm allowed to have 12 valence electrons. I have 2, 4, 6, 8, 10, 12, 14. When that happens, a lot of you do this. I had too many. So you just get rid of 2. You can't do that. Because if you look, this oxygen now only has 2, 4, 6. It doesn't have a full octet. Okay, so when this happens, don't just start taking away electrons. You need to follow step 5. Alright, so I'm allowed 12 electrons. I have 2, 4, 6, 8, 10, 12, 14. I have 14 valence electrons. That means I have 2 extra electrons, so I need 1 extra bond. Okay, because that's what step 5 tells me. For every 2 extra electrons, I need 1 extra bond. So 2 electrons means 1 more bond. 4 electrons means 2 more bonds. 6 electrons means 3 more bonds, so forth and so on. All right, so I'm going to put an extra bond in the middle. So see, now I have a double bond. But once you do that, you need to restabilize everything. You need to make sure everybody is still following the octet and duet rule. And so see, that's the problem is some of y'all, you want to add the extra bond and then count, and then you're like, wait a minute, it's still not adding up. Well, of course it isn't. You didn't restabilize yet. Okay, so let's look at what's going on here. So once I add my extra bond, my oxygen now has 2, 4, 6, 8, 10. So now it has 2 extra electrons. So now that I've added another bond, I can get rid of some of my lone pairs. Okay, so see, once I get rid of those dots, now it has 2, 4, 6, 8. So then I do the same thing over here. I have 2, 4, 6, 8, 10. So now I can get rid of my extra dots. So now this oxygen has 2, 4, 6, 8. Okay, I told you I'm going to go really slow, so let me show you how they each have 8 one more time. All right, so see, this oxygen has 2, 4, 6, 8, so it's stable. This oxygen has 2, 4, 6, 8, so it's stable. All right, now let me check my total. I'm allowed to have 12 electrons. I have 2, 4, 6, 8, 10, 12. Okay, now, I know you can rewind the video, but just in case you're too lazy to, I'm just going to show you what I did one more time. All right, so we got to this point right here once we made everybody stable. All right, and so then I got to the point where I was going to check my total. So I'm allowed to have 12 valence electrons. I have 2, 4, 6, 8, 10, 12, 14. I have 14 valence electrons. I have 2 extra electrons, so that means I need 1 extra bond. Remember, at this point, if you just try to take 2 away, one of them's not going to have the octet. So see, if I just try to take dots away right now, this one only has 2, 4, 6. Okay, that's why taking dots away was not an option until we added the extra bond. So see, I realized I have 2 extra electrons, so I put an extra bond in. And so now I can take away dots to restabilize. And by restabilize, I mean follow octet duet rule. So see, oxygen now has 2, 4, 6, 8, 10. So I'm going to get rid of 2. So see, now it has 2, 4, 6, 8. This one has 2, 4, 6, 8, 10. So I'm going to get rid of 2. So now it has 2, 4, 6, 8. And so then I'm going to recheck my total, because your total always has to be the same. You can't randomly just get new electrons or lose electrons. All right, so I have 12 that I'm allowed to use, 2, 4, 6, 8, 10, 12. All right, so let's look at another one. So we're going to look at CO2. So my first step is add my valence electrons. So carbon is in group 14, so it has 4 valence electrons. Oxygen is in group 16, so it has 6 valence electrons. But because it has a subscript of 2, I'm going to multiply it by 2. So 12 plus 4 is 16. All right, so second step is bond the atoms. So remember, single atoms go in the middle. My single atom this time is carbon. So I'm going to put carbon in the middle, and I'm going to bond my oxygen atoms to it. All right, step 3 is follow octet and duet rule. I don't have any hydrogen, so I don't have to follow duet rule, so we need to give everybody an octet. All right, so right now, oxygen has 2, so how many more does it need to get an octet? It needs 6. See, oxygen has 2, 4, 6, 8. Carbon, right now, has 2, 4. So how many more does it need? It needs 4 more. So see, now carbon has 2, 4, 6, 8. And then oxygen right now has 2, so it needs 6 more. So see, now oxygen has 2, 4, 6, 8. So just go back and recount. Make sure you realize every atom has an octet. I'll just recount for you. So oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. So everybody's stable. So then I move on to step 4. Check my total. I'm allowed to have 16 valence electrons. I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I have 20 valence electrons. The most common thing I'll see y'all do is, for some reason, you always take them away from carbon, poor carbon, is then you turn this into me. But the problem is, does carbon have an octet? No, it has 2 4 electrons. Remember, you cannot erase dots until you followed step 5 of adding extra bonds. Okay, so we have 4 extra electrons. So remember, for every 2 extra electrons, you need 1 bond. So I have 4 extra electrons, so I need 2 bonds. Now, this is where it gets a little tricky, and it goes into something that we don't really cover in regular, something called resonance structures. Because technically, you could put your 2 bonds on this side and make that a triple bond and leave this a single. You could put your 2 extra bonds on this side and leave this as a single bond and make this a triple bond. Or you could put 1 on each side and make them both double bonds. Now, in testing purposes, it's been decided that most of the time, CO2 is going to favor this structure more with the 2 double bonds. However, if you put a triple bond on one side, as long as you alter your valence electrons correctly, I will still mark that right because you are still drawing an adequate structure for the molecule. All right, so don't stress out over something like that. All right, so we added our extra bonds, but what do we have to remember to do? Restabilize. Now I need to take away some dots. All right, so remember, they all want 8. Oxygen right now has 2, 4, 6, 8, 10. So I'm going to take away 2. So see, now oxygen has 2, 4, 6, 8. Carbon, be careful on carbon. Carbon has 2, 4, 6, 8, 10, 12. So I got to take away 4 to make it down to 8. So see, now carbon has 2, 4, 6, 8. And then oxygen has 2, 4, 6, 8, 10. So I'm going to remove 2, and so now oxygen has 2, 4, 6, 8. So I'm just going to remind you that they all have 8. Just one more time. Oxygen, 2, 4, 6, 8. Carbon, 2, 4, 6, 8. Oxygen, 2, 4, 6, 8. So now let's check our total. I'm allowed to have 16, 2, 4, 6, 8, 10, 12, 14, 16. All right, so hopefully you're kind of catching on to it. Like I said, the multiple bonds is usually the hardest for my students to get. All right, so here, I'm going to give you a couple to try, so maybe try one at a time. So that way, if you make any mistakes on the first one, you have a chance to fix it before you make the same mistake again. All right, so here's our 2 structures. All right, so pause it, try N2 real quick, and then we'll come back together. All right, so I'm going to assume you've tried it now. So remember, step 1 is add our valence. And see, y'all, even if, let's say that right now, all you can do is get through step 3, and then you have trouble. That's still 3 steps you didn't know how to do before you started this video. Okay, so add our valence. So N is in group 15, so it has 5 valence. Because I have 2 of them, that means I have 10 valence electrons. So let's say you got that right. That is something to be proud of. Okay, you knew how to add up your valence electrons. All right, so step 2 is bond the atoms. So since there's just 2 N's, my only option really for a setup is this. Step 3 is follow octet and duet rule. Well, nitrogen follows octet rule, so that means it needs 8 electrons. Well, right now it has 2 from the bond, so it needs 6 more. This nitrogen has 2 from the bond, so it also needs 6 more. Okay, so now let's just check. Both of them have 8. So this nitrogen has 2, 4, 6, 8. This nitrogen has 2, 4, 6, 8. So everybody's nice and stable. All right, so number 4 is check my total. So I'm allowed to have 10 valence electrons. I have 2, 4, 6, 8, 10, 12, 14. So again, I can't just go erasing dots because I haven't added any more bonds. So for every 2 extra electrons, I need 1 bond. Well, I have 4 extra electrons, so I need 2 extra bonds. So I'm going to turn this into a triple bond. Once I add my extra bonds, then I need to erase some dots to restabilize everybody. All right, so nitrogen follows octet rule. Right now it has 2, 4, 6, 8, 10, 12. So I need to get rid of 4 electrons. All right, so see, now this nitrogen has 2, 4, 6, 8. This nitrogen right now has 2, 4, 6, 8, 10, 12. So I need to get rid of 4 electrons. So now this nitrogen has 2, 4, 6, 8. So I'm just going to show you one more time. So this nitrogen has 2, 4, 6, 8. This nitrogen has 2, 4, 6, 8. So everybody's still stable, but now let's check our total. I'm only allowed to have 10 valence electrons. I have 2, 4, 6, 8, 10. So we're done. All right, so hopefully you at least got partway through that one, even if you didn't get the total answer right, or hopefully you just got the total right. All right, so one hint I want to give you about the next one before you try it is, well, actually there's two hints. One is the order of the letters or the elements is the order that they'll bond in. So it's going to be H bonded to C bonded to N. The other hint I'm going to give you is you cannot add more than one bond to hydrogen because it's already stable. So don't try to do a multiple bond hydrogen. All right, those are my hints. Pause the video, try it. I'm going to assume you've done that at this point, and let's go. All right, so first step is add our valence. The hydrogen is in group 1, so it has 1 valence electron. Carbon is in group 14, so it has 4 valence electrons, and nitrogen is in group 15, so it has 5 valence electrons. All right, so your total should be 10 valence electrons. And again, if that's the only part you're getting right now, that's still something. All right, so I gave you the hint of how they're bonded. It's going to be bonded H, C, N, just like that. All right, so step 3 is follow octet duet rule. Well, we know hydrogen follows the duet rule, so let's do it first. So it has 2, so it's good to go. Carbon and nitrogen follow the octet rule. So carbon has 2, 4, so it needs 4 more. So see, now it has 2, 4, 6, 8, so now it's stable. Sorry. Nitrogen has 2, it needs 8, so it needs 6 more. So see, nitrogen has 2, 4, 6, 8. So let me just show you again. Hydrogen has 2, so it has its duet. Carbon has 2, 4, 6, 8. Nitrogen has 2, 4, 6, 8. So now I need to check my total. I'm allowed to have 10 valence electrons. I have 2, 4, 6, 8, 10, 12, 14. So again, you can't just erase dots. You've already made everybody stable. If you take things away, they won't be stable anymore. So remember, we add some bonds and then we can restabilize and erase dots. So for every 2 extra electrons, you need 1 bond. I have 4 extra electrons, so I need 2 extra bonds. So this is where my second hint comes into play. I cannot put extra bonds to hydrogen because it's already full and stable. It can only hold 2 electrons. So I have to put both bonds between carbon and nitrogen. So if you accidentally put one to hydrogen, maybe pause the video and try to fix it real fast before you see the answer. All right, so hydrogen follows the duet rule, so it still only has 2 like it's supposed to. Carbon follows the octet rule. Right now it has 2, 4, 6, 8, 10, 12. So I need to get rid of 4. So see, now carbon has 2, 4, 6, 8, so it's stable. Nitrogen right now has 2, 4, 6, 8, 10, 12, so I need to get rid of 4. So now nitrogen has 2, 4, 6, 8. So I'm just going to show you the stability one more time. Hydrogen has 2, it follows the duet rule, it's good. Carbon has 2, 4, 6, 8, so it's stable. Nitrogen has 2, 4, 6, 8. And so last step is I'm just going to check my total again. So I'm allowed to have 10, 2, 4, 6, 8, 10. And it works out perfectly. See, this is why I love Lewis dot structure so much. I know you're probably just like, oh my gosh, why? I hate this. But it's really great. It's fun. All right, so there's going to be one last type of Lewis dot structure that I'm going to put in, and here's just the pictures that I pulled off the internet if you prefer to look at those. But there's going to be one last type that we're going to go over, and that is going to be in the 3rd lesson video, which will be on polyatomic ions. So good luck.